Okay, I think we're about ready to start. Welcome everybody to the technical IT Masterclass of the AI Week 2021. My name is Patrice Neff. I'm a co-founder here at Skuro, and I'm really excited to have you on this session today. We have a great program prepared. I'm going to do a brief welcome and a session about how to become a data citizen. We'll follow that by a short break. I think we've all had a lot to learn and see and hear today. And so I think we can all benefit from a 5-minute break. But then after that, we really go to the main session of today, which is Amin Hassan, who will do a workshop on how to build your own app with the Skuro App Studio. I'm really looking forward to that. We'll then be followed by Lauren, who will introduce the Skuro Academy. And then at the very end, just a few final words from me again. So we should be done in probably a little bit more than 2 hours today. While I do my introduction, you might want to start creating your account on Skuro ID or start.skuro.com. You will also have time to do that later in the break. I will bring the instructions back on the screen. But what will happen over the next few minutes, you will probably get an email from Skuro inviting you to the instance, to the Skuro server, which we'll be using for the workshop. So don't be surprised, you don't have to action anything right now. You can just ignore that if it pops up on your phone or on your screen. But if you have time, then you can already now go to start.skuro.com and create an account. What's important is if you use a different email address than what we have on file for you, what you signed up for, or with for this event, then please let us know through the Zoom chat, just so that we can make sure the invitation goes to the right email address, to the right account. So now, without further ado, I want to address what does it mean to become a data citizen, or generally us in IT, when we're dealing with data, where can we upskill? Where can we still get better about working with data? And the reason this is relevant is, as an industry or even a wider world, we have come to accept the truism that data is the world's most valuable resource. Now, I work in the field. I still don't quite believe it. I think there is other resources probably still slightly more valuable, but we can all agree that data is definitely very important. It's something that we spend a lot of effort on, we spend a lot of money on, and that will only grow in importance over time. But at the same time, we see studies from everybody, from Forrester, from Gartner, from IDC, other organizations, that show that extremely limited amounts of that data, as little as 1%, is actually being used in practice. And by used, we mean, for example, this data being integrated into decision workflows, into daily work life, being found again, being consumed as part of a process. So how come that such a limited amount of this data is being consumed? Now, we believe there are two main reasons for that. One is the prevalence of silos. This data is distributed across many different systems. This data doesn't talk to each other. In many cases, you have proprietary internal systems combined with, for example, premium data sources that you're paying real money for, and combined with additional data from completely outside, like social media, web data, etc. And this data just doesn't really sit together. It cannot easily be combined in one place. The second big challenge that we face with data is that a lot of it is unstructured. And what we mean by unstructured data is it does not sit in a nice relational database where you can just run a query on it, where you can run a calculation, but it's textual in nature. It's even maybe voice, video, scanned documents. So it's data that is hard to work with. Now, the silo problem, that can be solved more or less easily. It usually is more a political issue of different teams working together, of making sure the data can be accessed across different areas. There are plenty of projects, for example, with data lakes that have tried to solve this. Often they struggle a bit because there is no real business value from it. But fundamentally, from an IT point of view, we kind of see it as a relatively solvable problem. The one challenge that can be difficult is, next to politics, is how does this data actually relate to each other? So when you have, for example, a customer record, where do you go to find related news information, related documents, etc.? An insight engine such as Squirrel can solve a lot of those challenges by combining, aggregating, and bringing all of that data into a central actionable index. But we will not be focusing on this particular problem too much today. If this is something that concerns you, where you feel that's a real pain point for your organization, please do not hesitate to reach out to us. But what we want to look at today with a bit more details is adding structure. So when you have this unstructured data, you have text content, for example, the first thing you want to do is to give it additional points of structure where you can then actually start working with this data. For example, you might want to run what's called a named entity recognition, or we at Squirrel call that known entity extraction based on our technology stack, where you want to understand this particular earnings transcript that we have on the left-hand side is related to the Hastings group. That's one big piece of also joining the different data pots or the different data silos. Now, the second big improvement that you can make on this unstructured data is to run text classification to identify topics that are of interest to you. Now, which topics those are will depend entirely on your use cases. But if we're in a financial context, for example, then I might be interested in understanding from this text document, where is it talking about debt? And that is a text classification model that will be run on this text to identify these are the different sentences, the different paragraphs, the different elements that have this particular topic. And then finally, the last element is you want to bring this back into context. So you want to start highlighting these topics, highlighting these identified signals back in the source document so that you can use this as part of your workflows, as part of your decision-making processes to really have the right data in the right context. Now, the insight engine that we have developed at Squirrel can solve this entire challenge from beginning to end of bringing data together, understanding this data, and creating actionable dashboards and integrations into your other systems. But the element that I want to focus on today is the signal detection, specifically in the context of text classification, and how we enable that with the AI Studio at Squirrel. Now let's imagine that we're presented with a large amount of unstructured data that is in some shape or form textual in nature, and I now want to understand what are the topics in there, or where are the specific topics that are of interest to me. Now, in a completely industry agnostic manner, I have chosen today a topic that has nothing to do with any of our work, or for most of us at least, which is I want to identify in these text documents, where does it talk about association football, or what in North America we call soccer, and American football. In much of the world, both of these will be termed football, and it's not an easy challenge to identify in a sentence in a document which one is being referred to. And today, I want to solve with you together once and for all this very difficult problem. Now, the way we do this is in the AI Studio, that's you start with a hunch, and we call that a candidate set. So first, you have an inkling that maybe when they're talking about association football, they might be writing soccer, they might have a few other terms, FIFA, American football, you will probably find something about the NFL, etc. So that's just formulating your initial assumptions. What you then do with that is you create a ground truth, which is the training data. That becomes the real source, the golden source of what does it really mean for something to be association football, soccer versus American football. From that ground truth, you create a model using some model templates, which we will see in a minute what they can look like. Now, when you create models, you might want to compare different models to each other to understand which one performs best. And you especially want to compare the model performance over time. That is validation. And finally, you want to publish that model into production. You want to actually start using it to be serving signals and predictions to your users. So let's actually look at that in practice. We will start by creating such a candidate set. And I'm now presented with all of the data that has already been indexed, that has been made available to Squirrel. And I start looking for these hunches that I mentioned. So I'm looking for football or soccer and look a bit at the results and suddenly think, maybe let me add FIFA as well as the regulatory body. And that shall serve, that gives us quite a few results actually. That shall serve as an initial foundation of what we will work with in the training. I'm now saving this as a football soccer candidate set. Now we go to the next one and we create the comparison candidate set, which is for American football, where I'm now looking for American football or NFL, which should present me with quite some good results that I can use later for training. Now, another way how we can achieve much of the same is by working with our smart filter technology. And what you see me here doing is that I'm actually on Wikipedia and I'm copying everything that they know about association football. Back in Squirrel, I simply copy paste this into the search field. And as you can see here, Squirrel has now already learned what is the definition, what are common terms for association football. I can manipulate a little bit to remove, for example, this weird Freemasons term. And what that now gives me is already a first iteration, again, even slightly more than a hunch, a list of keywords that I would expect to see in the context of soccer. So let me save that again as a different version of this candidate set. And I can now repeat this exercise by doing the exact same thing with American football. So again, I'm simply copying everything that Wikipedia knows and has written about American football completely indiscriminately, and I paste it into Squirrel. And what we'll see from the resulting tag cloud is that just by getting this data in as essentially training, we've already been able to identify a lot of relevant terms that you would expect in American football, but not in soccer, like linebackers, linemen, etc. What to me personally was surprising is that even the word football is not being picked up by any of the two smart filters. So it's really been clever enough to realize that football as a term is too common, that it does not contribute anything. So instead it picked up a lot more topic-specific keywords. Now at this point, I want to take a moment to look at what kind of models do we want to train for text classification. Now, usually when you talk about AI, machine learning, a model is really, you have a lot of training data, which you've, with a lot of work, with a lot of effort and or a lot of money, you have acquired, you have created so that you can feed a machine with this training data. That's towards the right-hand side of this particular chart, starts with naive Bayes and then goes from SVM, random forest, all the way to deep learning. Now, what we at Squirrel think is that when you're creating such a model in production, you're running a business, you're part of a business, you can't always invest hundreds of thousands of hours into creating the right training set for your use case. Instead, what you often want to do is you want to run a very quick proof of concept. You might have a user, a business user coming up to you saying, hey, we need to solve this particular challenge. I want to understand in our data, what do we have about topic A? Could we just identify that in the text? And what you don't yet know is it actually worth going the extra mile? How much do you want to invest into that? So what we have done is we also allow you to create very simplified models, and on this I'm air quoting, which do not use a lot of training data, but they're more rule-based. They can, for example, be an ad hoc search. What we saw at the very beginning, just looking for football, soccer, FIFA, that can already serve as a initial exploratory mechanism to find, do we even have the data to support my use case? And then the smart filters that we just looked at, again, require almost no data, but they can also already start providing value. Having said that, you will at some point want to or have to choose between the different types of models. And I've simplified this now to A and B, where A is something like keyword-based, it's something like smart filters. And the huge advantage you have is it's a very, very fast learner. You saw me create a smart filter earlier, and that took literally seconds and was already returning pretty good recommendations. But it's very limited in its long-term accuracy. So you will not get more value, better models over time. Whereas a proper machine learning model, to call it that, will take much more time until it reaches a reasonable training level. It requires thousands of examples until it's sure enough of itself to understand what do you actually mean with that topic. But once you have invested that, the advantage you get back is that it essentially never stops learning. Now, in most cases, that growth is not linear, like this chart here might imply. It's usually more logarithmic. So this growth will slow down, but it will continue to grow. We've always wondered at Squirrel, why do we have to choose? Can't we pick model A while we're coming to terms with the topic, with the classification, and then once we have enough knowledge, once we have enough data, we would like to switch over to the model that at that point will perform better. So the AI studio that I'm demoing today has been built on exactly this premise. It's been built on this whole idea of let's start quickly, let's create simple, pragmatic models that can be deployed, that can be used in production in usually a POC or MVP, minimum viable product environment. But then once you have user feedback, once you've committed to, yes, let's actually invest more time into this, then you want to switch over to the more rich models. So with all of these prefix, let me now show how do you create a ground truth, which serves as this container for your learnings about the topic. And here my ground truth will be around football types. I want to find different types of football. So I will split that out into different labels. I will call one association football. I will call the other one American football, and a third set, which is neither. And now I'm defining proximity search rules. That's the initial keyword-based models that we're creating, where as I'm creating or labeling a sentence, I'm also creating a rule to say NFL draft is a relevant term that when I find that, I want to mark it as American football. I'm now continuing this in the American football candidate set. I'm looking for the next sentence that might help me. And again, I'm tagging a label, but at the same time, I'm also creating an initial rule. I've now sped up the recording so that we don't spend too much time just watching me create rules. I'm doing this now for a lot of these initial highlights that were identified from the smart filters, from the initial hunch from my first query, and adding additional rules, additional labels, etc. We'll see then quite quickly, I've ended up with about 10 or so of those rules. Now at this point, I could go on and deploy this model. And I could start using this as a foundation to get some buy-in from the users, to have them understand what we're doing here, to be able that they can provide feedback, which we can then use to polish the model further. For this demo instead, what I will now do is I will already turn off these proximity rules, and now we just label. So if I do it this proper machine learning way, then I look at every sentence that is presented to me, and I label it as, does this talk about American football, or does this talk about association football? As I do this, I always have access to the whole document, so I can see it in context. I'm not limited to just the one sentence. And I can then start tagging, and again, I sped this up so that you see that this is really a process that is very seamless, that is very quick, to be able to start collecting different examples, different labels. When I do this, I'm not limited to just the sentences that have already been highlighted from the candidate set or the smart filter. I can also identify additional sentences, different terms. I can use the query capabilities to also formulate additional hunches. And eventually, after a rather quick time, I've now collected about 90 or so labels or sentences and split almost evenly into 3 different groups. So we now have association football, American football, and the last one, which is also important for the model to learn that not everything is about football. There are also other topics in the world, and it should put all of those into this additional set called neither. The names, by the way, they are completely made up by you. So whatever topic you have to train in the AI Studio, you can choose which labels you're providing. Now let's go and create actual models. We ship in the AI Studio already with existing model templates where our data scientists have gone ahead and created a really good configuration for specific types of classification that you might want to do. So you pick one of those templates and define the ground truth against which you want to train this. As you can see here on the screen, I can do that more than once. So I can now choose various different templates and create different models. What's very important here is you, or rather your data scientists in your organization, can also add their own model templates. So you're not limited to the ones that our data scientists have created and provided. You can add additional ones and then benefit from this entire workflow, from the scalability of the AI Studio approach. After having created the models, they're all being validated already. This means that we check how well does this model perform. And we can see some of them are really bad at 30%, others are already getting up to 67% or so, which is not great. There will be lots of false positives, but it's something to get you started. As you explore the details of this validation, you get quite a lot of information about what went on, where is it getting more confused maybe, are there certain labels that are still weak, and which predictions did it fail to make. Now, in a production scenario with 67%, I would not be happy. But as we're doing a proof of concept, I want to get some initial feedback from the users to see, after having spent now, let's say less than an hour, do I actually need to spend more time on it? Is this something which solves the real problem that the business users have? So let's go ahead and publish this. I publish this now with a model name of football types into the Squirrel environment. What this will do is 2 things. First, it exposes this model as a API. So this can now be consumed across the organization to make predictions of football types. But the second part is this is now also made available to your Squirrel pipeline. And the Squirrel pipeline is the section where all of the new data being indexed by the Squirrel Insight engine flows through. So everything that Squirrel indexes in your instance flows through this workflow, through this pipeline. And here I have now added the football types classifier. And this means that every new document that is being indexed now will be predicted or classified against these football types. So you're seeing that it's really quite easy to start with your first model by creating a candidate set, formulating your hunches, creating a ground truth from that, providing the actual labels or the training data, using our template library and templates that are provided by your data scientist to create a model, validate those models over time as well against each other, and publish that into production. This solves the first of 3 interlinked circles. This is the development cycle that we've just seen, where you start at the bottom left with the business demand and start discovering the data, training this model, validating it, etc. With the publish, we've gone into the release cycle. So we have now published this model into production and it can start to be used. But what you now need to do is you need to operationalize this. And this is often where modern data science projects fail because you don't have the tools or the discipline to actually monitor those models in production to collect the feedback. And that's the next step of what we're going to look at. We see here a dashboard where these predictions or these classifications have now been deployed. So as a user, I can now look at this and start to see which type of football is a certain sentence talking about. And I can provide feedback. So if I see that something is classified incorrectly, I can say that. I can even provide an alternative to say, actually, this should have been this other topic. And all of this is now being collected. I will now show, again, in a sped up way, how one user could do this. More realistic in production is that you would have lots of users doing that in parallel. And based on simply what gets presented to them, you usually don't see them go through in such a disciplined manner, but more if a prediction is being presented to them as part of a workflow, then they might see, actually, I wasn't too happy about this one, and provide the feedback. Now, we as the model creator can go back to the ground truth in the AI Studio. And we now see this tab here called feedback, where all of this user feedback has been collected. And for every single one of them, I now have a recommendation based on that feedback on what I should be tagging. And as a model creator, I can now accept that feedback, in which case it will become part of the ground truth. The label will be stored, the training data, or I can reject it. And to us, it's really important to acknowledge that the feedback cannot just be automatically added to a model, because when you want high quality predictions, you need to make sure that your training data doesn't become confused. You want to make sure that the training data stays consistent over time and that not kind of the different opinions of different users start skewing your data set. So to us, it's important that you as an owner of this model always kind of have control of what really ends up in the ground truth. So we've processed a bit of feedback here, at which point I can now go ahead and retrain my models. So all 4 of those models, as I choose the retrain option, will now be using, again, the latest ground truth. I now have probably about 30 or 40 data points more. And once I've done that for everything, I can now go to the validation screen, and I will see that the accuracy has grown ever so slightly. Not too much, but it has gone a little bit better because you've provided it with more information. And that underscores the point I made earlier on why you really want to go into an initial proof of concept with as simple a model as possible, just to actually be able to collect feedback, because to then get the really well-performing ones with training data, that will take time and that will take effort. And this now continues this cycle that I mentioned. We can redeploy this, republish it. We can expose it to the users again who provide the feedback, who will be assessing whether they're happy with the recommendations or not. And then I'm back in the AI Studio and processing the feedback here, adding that to the labels, and with that always making the model better. And this shows how the Squirrel AI Studio really fulfills the whole flow of what's called ML Ops. So starting with the business demand, you initiate the development cycle. Once you're happy with that, you release it, the release cycle, and then finally support for the operation cycle of providing feedback and even monitoring the models in production to make sure that they stay consistent, that they stay high quality, even 2 years after you've created them and have forgotten all about it. So in conclusion, we saw originally why data is not being utilized enough, why only about the % or so of the data that we have access to in our work is really part of workflows of decision processes. We see how a good insight engine can solve that by crossing data silos and by lending structure to unstructured data.